everybody, it's Tyler here at the Lakeshore Qualifier event, checking in team number 2077 Laser Robotics from Wales. I'm here with Jameson, Lucas, and AJ, and we're going to be talking about this modified 2020 robot. Going through the power cell journey here, a really cool hopper mechanism they have here, so I really want to highlight that. Of course, we'll be covering some of the intake and the shooter, all this and more coming up on Behind the Bumpers.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
We'd like to thank Stryker for their continued support of First Updates Now. Stryker's internship portal is now open and available. Discover internships and rotational programs located around the world, including their headquarters in Michigan, when you go to careers.stryker.com and click on Students and Graduates. We'd also like to thank Kettering University. Kettering University is where robotics students come for their education. Over 30% of those who attend Kettering University were in high school robotics, and you can keep going with their BattleBots, VexU, esports, and First Mentorship programs. If you are a U.S. student grades 8 through 12, scan the QR code to stay up to date on info and events happening at Kettering and get a free Kettering t-shirt when you sign up by December 12th, 2021.
So starting out here, we're going to talk about the intake. So talking about some of the iterations you've gone through with it as we kind of go up into the hopper then.
Yeah, so this was our 2020 robot. We started this by designing it out of cardboard and doing a lot of testing with that. When we finally found out the dimensions that we liked, we switched over and put it into CAD and plasma cut all this. And one thing our team really prides ourselves in is that it is all student built and designed. So it comes in here, it gets picked up by these wheels and is fed into this Omni wheel that transfers it across and into the trough system.
So looking at this as it comes in, if you were to have like multiple power cells coming here, do you have any issues with jamming, or are you able to clear that up pretty well?
Every once in a while you might get one under the fender, but that's why we made this skid plate on the bottom. So if that does happen, you grab the one ball and then you just back up and grab the other ball.
Well, Jameson, thanks for telling us about that. Next we're going to go into Lucas, is going to be talking about the hopper design. So tell me a little bit more what's going on there.
All right, so looking at the trough design, we wanted to find something that would hold a lot of balls as the max as we can hold is 5. So we wanted something that had a lot of space, so we came up with this trough idea here. And probably the biggest decision or the hardest points were getting the correct angle for the balls to roll down and constantly be fed into the shooter there. So that took a lot of work to roll all the aluminum also and to get the angles correct. But it's pretty intricate and works quite well in our advantage.
So how did you from an angles wise, obviously as mentioned, gravity fed going into here. One of the things when you have like two angles like this, once again, jamming can be an issue. Some teams we've seen like beam breaks or stuff like that in between, but it doesn't look like you have any sensors for this. Like how did you get it down to that iteration where you're like, hey, we don't need anything, it just works?
A lot of testing, a lot of iterations with these angles. We would have a piece here where we would just kind of adjust that. We had a smaller piece here, and we could adjust that angle, and that helped us find an optimal angle essentially for this. And then this was just kind of the final design, so we could roll it all out in one piece, and that worked the best for us.
Yeah, so lastly we're going to go into the shooter. I'm really interested to hear about the transfer as it gets into that and then shooting out, and then also as well too with the two-wheel design, talking about how you got your compression down correctly as well too. So AJ, tell us a little bit more about that.
Yeah, so our shooter is really nice. We've done lots of calibrations with it, and it's gone through a few designs. First it gets fed up here, otherwise it wouldn't have enough oomph to get through, and that also makes sure that we have enough force to actually get it in and that it doesn't jam in that section. We have our two here. Originally, we had a less powerful motors here that were closer, but we found that it would dip too much when we were trying to launch, which led to consistency issues, especially when shooting balls after each other. So we've upgraded them to Neos. We got our angle thing, we have that to make sure things come out of it. So we're shooting things pretty straight in this. This is actually all on an angle. So we have a linear actuator to adjust the height. Originally we had a screw on the bottom that we had the potentiometer that went back and forth, and we used that to control the angle that we shoot at. But that just was too slow for our liking. So we've upgraded it to this, and it actually has a limit switch on it so we can zero it out before each match.
The compliant wheel that you have here, obviously it's moving the ball in. Does that help out with like the shooter as well too. Does it kind of like prep it a little bit? Because obviously, as you mentioned before, when you try to shoot consecutively, you're going to lose a lot of speed for each one.
Yeah.
Do you see this actually helps out at all with that?
Yeah, yes, it does. We do have a couple different sizes in that location, but when you pick it up, it gives them the grip and the force to get pushed around here, which really helps, and also it keeps them from, when they're sitting here before they get fed in, from flowing too far in and not getting the oomph that they need beforehand.
So as we wrap up here, I don't think we're going to shoot one out in the pit area, but can we see these actually intaked and see kind of how it travels through? So this is actually gripping it all the way up into that shooter, essentially.
And that little oomph pushes it up where it gets grabbed by these.
Makes sense. Well, 2077 Laser Robotics, once again, thanks for taking the time to tell us about your robot. Love the aesthetic look overall as well, too. So a great team here coming out of Wisconsin. And can't wait to see, of course, how you do here at the competition and in future ones as well. Thanks for taking the time.
Thanks to Kettering University for their support of this video. Don't just sit in class. Kettering University is the only school in the U.S. that allows you to work as an engineer your first year with their 3-month on, 3-month off co-op programs. If you are a U.S. student grades 8 through 12, scan the QR code to stay up to date on info and events happening at Kettering and get a free Kettering t-shirt when you sign up by December 12th, 2021. We'd like to thank Stryker for their continued support of First Updates Now. Stryker's internship portal is now open and available. Discover internships and rotational programs located around the world, including their headquarters in Michigan, when you go to careers.stryker.com and click on Students and Graduates. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.